I'm recording it. It's going live on YouTube, so you can check from there later on. Okay, so let's try to make the session as much interactive as possible. There are total 10 Python problems. Uh, I expect you to have some basic knowledge in Python, like using a list, array, for loop, while loop. So this kind of basic knowledge is expected for you from you in this workshop. All right, and then we will study. So we are having 10 questions. 5 questions are on recursion, and 5 questions are on uh, this sliding window. Just let me check if it is. Okay, so thanks again everyone for joining. We are live now, so we will be discussing uh, recursion, and 5 questions on recursion, as I mentioned, and 5 questions are on sliding window. So first of all, I will start with the recursion. Okay, so may I know, like, for you guys, how many of you know about recursion? And for people of DSA batch, are you able to solve all the question in the assignment? Let me know in the chat box. Like, or others, like, do you know about recursion? What is recursion in general? Okay, okay, so let's see, so I'm going to sorry. Okay, SQL. I'm talking about recursion in Python. This is a Python. Okay, yeah, no, don't worry. We will discuss sliding window in detail. First, let's discuss. First hour we will spend on recursion. Then second hour we'll spend on sliding window. Okay, so just let me give you a little background. Who are so before I start the assignment discussion, that what is recursion in general? For example, uh, just just give me a second. Let me make. Okay, so let us try to understand a little bit about recursion. In first of all, that what it is. Then we will solve the 5 questions which are there. The recursion in general is what. So, for example, let us say I ask you to calculate factorial of a given number. So let us say you're given a number 5, okay, and I ask you to calculate factorial of number n. So can someone tell me how will you do in a using a normal Python code, using for loop or while loop? Can someone write down the code? Can everyone tell me how to write? Let's say I have to calculate a factorial of 5 using Python. How do you write it? Okay, so let me tell you. So how do you do it? First of all, what you do, you create an initial value fact equal to 1. Okay, because this is a product. Then what will you do? And you will iterate in this particular n. So what you will do for I in range, what shall I write down here?
Range of n.
Range of n plus 1.
Range of, where will range start from? Tell me.
0.
Oh, sorry, it would start from 1.
It has to start from 1 because I have to check factorial for 1 from 1 to 5, right? So what will I do? My range will start from 1 to
1 to 5.
N plus 1.
n plus 1 because I need 5 numbers, right? So I need, what do I need? I need 1, I need 2, I need 3, I need 4, I need 5. How will I get it? This will mean n is starting from 1 and it is going till n plus 1. Is it right? Okay, so this is it. After this, what will I do?
Fact equals to fact into I.
Fact is equal to fact into I. Right? Shall I print now? Let me check chat box. If n is equal to 0 or 1, return 1. No, this is recursion. I'm not talking about recursion. I'm just talking about the regular way. Yeah. So let's check out. It is not giving me the answer. Tell me what is the issue with this code?
N value should increase. For I value should increase, right?
Sorry?
Value should increase, right?
No, this is for loop. You don't need to increment I.
I think there's only one asterisk, like in the multiplication.
Okay. Yeah, right. So for I in range, this factorial is equal to fact into I, right? So what will happen? First, you will start with I equal to 1, right? Then fact will become fact. So what will happen? Fact will become equal to uh, 1, right? Then fact will become 2 into 1, right? And then it will become 3 into 1. 3 into 1, and then it will be 3 into 2, like the previous value, then 4 into 3, 2 into 2, right? Then it will become 4 into 3 into 2, and then it will become 5 into 3 into 3 into 2. Okay, so this is called creating factorial using Python, using normal for loop. But I want to use recursion, right? So in recursion, what happens that you try to see if any step is getting repeated, right? So for example, what happens, let's say if you have to calculate factorial of 5. So factorial of 5 can be written as 5 factorial is equal to 5 into 4 into 3 into 2 into 1. Okay, now what is this particular part? This is 4 factorial, right? So 5 factorial can be written as 5 into 4 factorial. Okay, then 4 factorial can be written as 4 into 3 factorial. 3 factorial can be written as 3 into 2 factorial, and 2 factorial can be written as 2 into 1 factorial. Okay, and what, and it will keep on going. For example, a point will come, for example, now 1 factorial will be equal to 1 into 0 factorial. Okay, now anything beyond this will not be applicable, so we will have to put a condition here. So this is the general trend that you have seen, right? So what is recursion? That we try to identify a pattern, and we try to generalize it using by one level. Okay. So for example, any n factorial is equal to n into n minus 1 factorial. And we use this particular concept to create anything. Any doubt till this point? Just a second. Okay, so this is how my factorial is calculated for any number. Now I need to go think from a coding perspective. Now I know that for recursion I need a base condition. Can someone tell me why I need a base condition? What is a base condition? Can someone tell me? And why do I need it?
Go into infinite loop. We need to terminate that before that.
Yeah. What will happen that if you just keep on doing this way, then what will happen? A point will come. You will say, okay, uh, 0 factorial is equal to 0 into minus 1 factorial, and you will never end, right? Yeah, then you will go minus 1 factorial is equal to minus 1 into minus 2 factorial, right? So this will keep on terminating till infinity and you will not be able to resolve it. So therefore you need to define a base condition. What is the base condition for a factorial? That factorial of 1 is equal to 1 or factorial of 0 is equal to 1. This is your base condition that you use. Okay, so how do we write this particular step using factorial, using recursion? Okay, so let's say I write down def fact. Okay, let's say I take a number n. First of all, I have to write down a base condition. So what is my base condition? If n is equal to 1 or n equal to 0, return 1. Okay, this is my base condition. Now after this, I have to write down my recursive condition. Recursive condition. So in recursion, what happens? I call the main function inside the function. So what do I say? So what will I write down here? Return. Otherwise, what I have to return n into factorial of n minus 1. So what I'm doing here, I'm calling this function inside the same function with a lesser degree. Okay. Now let me just run it. So if I just call it fact of 5, I will get 120. Let's say I call fact of 6, I'll get 720. Okay, so how it is working in background is that what happens, let's talk about factorial of 5 here. Let's say when I call factorial of 5, so what will happen here is that, okay, it will call this particular value, right? So factorial of 5, whenever let's say n is equal to 5, so this it will not, like, this is n is not equal to 1 or n is not equal to 0, so it will go here. So it is returning 5 factorial is returning me what? It is returning me 5 into this function fact of 4. Correct. Now the point is that I do not know the I still do not know what is the factorial of 5, but I know that factorial of 5 can be written as 5 into factorial of 4. Now I do not know the value of 4 factorial as well. So what will I do? It will call the function again back, right? So now what will happen? Fact 4 will be equal to, you can simply say fact of 5. Fact 4 will be equal to 4 into fact of 3. Okay. Now fact of 3 will be equal to 3 into fact of 2. Fact of 2 will be equal to 2 into fact of 1. Okay. And now I know the base condition. Yes, please.
Factorial of 5 is 120.
I didn't run it. I haven't run it.
Okay.
So right now what will happen, now we know this base condition on through our code. We know that if n is equal to 1, my value of fact 1 will become 1, so this will become 1, right? So first it will come down, now we will go up. Now this is 2 into 1, so fact of 2 becomes equal to 2. Now this fact 2 will automatically go here, so 2 3, so factorial of 3 becomes 6. Now this 3 will be imputed here, right? So it will become 6. So 24, so factorial of 4 is 24, so it will go here 24, and overall factorial 5 becomes 120. Okay, so there is backtracking, there is forward propagation. Like we go, first of all we break the question into the smallest of the value, right? Once we break that, then we go up to solve the main value, main function. So this is how it is done. Any doubt anyone in the like understanding of what is recursion through this method before I start the assignment? So this question is very this factorial was recently asked in my interview itself, right? So it is very frequently asked that they will give you a question, and then they will uh, ask you to, you will solve it using a method, and then they will tell you, okay, now can you solve it using a recursion method? Okay, so that you need to tell that yes, I can solve it using recursion as well. So if you know, have the basic knowledge of recursion, it is good in Python interviews. Okay, so now let's start solving the question. So the question number 1 that is there today is, you have to calculate the power of a number. So you have to write a recursive function with, you're given a base and exponential. So you need to calculate this. For example, you're given base as 2, power as 3. You need to calculate 2 raised to the power 3 using recursion. So how are you going to do it? Can someone tell me? You guys can take a couple of minutes and tell me. So let us try to understand this particular question, right? So what we need to do, suppose you need to calculate a number as 2 raised to the power 4. Let's say you need to calculate this. Okay. So, so can I write it down like this? 2 raised to the power 4, just like we did for factorial, we broke it into uh, a number n in n minus 1, something like that, right? So can I do it like this? 2 raised to the power 4 is equal to 2 into 2 raised to the power 3. Can I do like this? Then this 2 raised to the power 3, I can further go here and I can write it down as 2 raised to the power 2 into 2 raised to the power 2. 2 raised to the power 2, I can write it down as 2 into 2 raised to the power 1. And 2 raised to the power 1, I can write and 2 into 2 raised to the power 0. We know that 2 raised to the power 0 is 1. Okay, so this will become 1. So this becomes 2. This becomes 2 into 2, 4, right? And that's how you will back propagate and calculate the values above. So whenever you're given a base, let's say you need to calculate base, there is a base raised to the power some exponent. So how can you reduce it? You can simply say that, okay, this is equal to b into b raised to the power e minus 1, right? And you keep on going back. For example, then you will say that, okay, b raised power e minus 1 is equal to what? It is b into b raised power e minus 2. Okay, and that's how you will reduce it. So what is the base condition? If my exponential is equal to 0, okay, then my power will become by default 1. So let me just go through the code. So let's say if I have to write down a function def power, and you're given a base and you're given an exponential. Okay, so first of all, we'll write down the base condition. Base condition. So what is my base condition? If exponent is equal to 0, so what will be my value of power? If
One. It should
so what
return
I will do, I'll return
1.
1. Okay, this is my base condition. Now I will write down recursive condition. Recursive condition. So okay, no, I think one more base condition can be there. If power is equal to 1, what will you do?
You will just return the number and the power is
So
one.
you'll say LF
Expression equal to
exponent is equal to 1. So what will you do? Return. What will you
Base.
do? If your power is 1, what will you do?
Return base.
base number.
Base. Correct?
I think without even including this like this one in recursive condition, this would be included.
Yeah, it will be included. Yes,
Yeah.
you're right. You're right. Okay. Otherwise, what you will return? Return base into. Now I need to call the function inside this function. So what I will do, I'll call this function, but here the difference is that it will be exponential minus 1. Am I right? So these two are the base conditions, you can say, and this is the recursive condition. So recursive condition is nothing, like people who get scared about with recursion, it's nothing. You just need to think one level below, right? How can I break into a sub problem? How can I make it a loop so that it keeps on looping, and one point comes when it picks one answer and give me the result. So let's say we got this. Now suppose I call this function power of 4, 5. Okay, so it will give me 124. 4, 5 means 2 raised to power 10, that is 1024. Okay, so any doubt anyone in this particular question, let me know. I'm pasting y minus 1. I explained to you, right? How do you write it? For example, whenever you have any things, for example, 2 raised to the power 4, you can write it down as 2 into 2 raised to the power 4 minus 1, right? That's what we are doing here. We are breaking it into, so any, let's say 2 raised to the power n can be broken down as 2 into 2 raised to the power n minus 1. So we are breaking down a problem into another sub problem so that we can keep on looping. This is what we do in recursion. Is it clear? Let me know. Any doubt, anyone?
All clear.
Okay. For how many recursion is totally new right now? I just want to know, or like you're not able to understand, because I expect some level of Python knowledge. That's why. But still, anyone who does not understand at all. But okay, you understood now, right?
Yeah, it's clear.
Okay. Yeah, just try to cope in, guys, because I this is just an assignment discussion, so I'm not going into two basics, but still, if you get stuck up at any point, please ask doubt, right? I'll be happy to explain, because, but still, just understand how, like, we'll be solving 4 more questions on recursion, right? So you will understand how it works. Okay, so let's solve another question. Question number 2 now. Question number 2 says you have to write down a recursion function, write a recursive function product of array that returns the product of all elements in an array. Okay, so let's say this is an array. You want to write down a recursive function that returns you product of all elements. You can do it using a for loop very easily. Okay, so how will you do? For example, let us say you have an array like this. Let's say you have an array equal to 4, 5, 3, 2, and let's say 6. So suppose you have to write down a normal Python code that returns you product of all the elements in the array. What you will do? You will do prod equal to 1 initially, right? Then you will do for let's say a in array. Okay, prod is equal to prod into a. Am I right? Print prod, right? So you simply calculate it. Is it right? 4 5 are 20, 23 60, 62 120, 120 to 6, 720, right? This is a normal method to do this using a for loop, but you can simplify it using recursion as well. Can someone tell me? So let's try to break it using recursion. How can we do using recursion this particular question? Okay, so whenever you are having an array, for example, let us say you are having this array here. So let's say there's an element 4, there's an element 3, there is an element 1, there's an element 6, 11, 12, for example. You need to calculate the product of all elements. Okay, so can I say that the product of all elements of array, okay, is equal to first element multiplied by the product of all the elements of the array that starts from this one. Can I say this? From one, like of 1 onwards. Can I say something like this?
Up to the end, right? From
Up to the end. So this means end only.
end.
Like,
Only.
when you just write down an array of 1 slash this means up to the end only, correct? So can I say this? So let me break it even further. Okay, write down a proper nomenclature. So let's do it this way. So I have this array, right? What I need to do, I need to calculate the product of all its sums. So can I say that product of all the elements of array, let's say product of all the elements of array is equal to array of 0, that which means the first element, which is here, into product of all the elements of array of 1 till end. Can I say this? So what I'm doing, product of this whole array is equal to first element multiplied by the product of this remaining array. Can I say this? Yes, no? Let me know, please.
Yes.
We can say it, right? So now let's go further below. Now let's take this one. Product of array of 1. Can I write it down? Array of whatever it was, 1, 0. That is the first element of this array, right? So we have this array now, right? So what I will do, I'll take the first element multiplied by product of array of 1, into 1. Can I say this? What is this part? This is this array. If you look carefully, what is this array? This array is what? 3, 1, 6, 11, 12. Am I right? Okay. So this is this array. Now, when I do 0 element of this, it means 3. This means 3, correct? And when I do the 1 to end of this array, what does it mean? It means this particular array. Any doubt, anyone? Let me know. Let me know if it's not clear, like if it is going above your head.
Like, can you explain once again?
Yeah, let me explain once again. So think like this. So let's go. So what have we been doing till now? We have been discussing how to break problems into sub problems. Okay, this is what we have been doing. So let us say I do like this, array of this. Now I write down, we have to calculate the product of all elements. So I will say, can I say that product of all the elements of array is equal to the first element, that is 4, into the product of which array? Product of this bigger array. 3, 1, 6, 11, 12. Can I say this? Yes or no? Okay. Now I need to calculate the product of this. So the product of this particular array, which now what is this array? If you are given the original, if original array name is ARR, right? What do you call this array? ARR 1. Am I right? Is everyone clear till this point? Anyone, any doubt? If no one is saying there can be either two meaning. Either you are not understanding at all, or either you have understood everything.
No, it's clear.
It's clear, right? Now let us say I have to get this particular product because I don't know, right? I don't have the function to calculate the product, right? So what I will do, let's say product of this particular array. So what was its name? Array of 1
Colon.
this colon. So what will be this particular? This will be 3 into. Now tell me this. What was 4 here? This is actually ARR 0. Am I
Zero.
right? Right. So can I write down this the product of this as 3 into product of one, 6, 11, and 12? Can I write it down like this?
Yeah.
What will be the nomenclature of this particular array? Given that this array's name is ARR, this. So how will you write down this particular thing?
Here of 2 column.
Two
No.
column.
No.
No. ARR of
1.
you can write it down. So let me. So first of all, let us write it down using this. Assume this is your main array. Okay. So let's say this was your main array. 1 this. Can you write it down as this? Yes, right. So what is this? This is the previous array which I am using, and I'm just slicing it from 1 to n. Is it clear, everyone?
The
No,
reason
this
you're
part
doing
is not
for the second one column because it has to go out till last, right? That is the reason.
Sorry.
The second 1 colon, you're trying to go till last, right? 6, 11, 12. That is the reason you're using 1 colon, right?
Yes, yes. So the name of this array is this, right? From this array, I want to calculate this particular array.
Hmm.
How will you calculate that?
Okay, yeah. Array of
You
1.
guys are getting confused because I'm using 2 this, and you're thinking that why is he doing this? Okay.
Yes.
Now think like this. First of all, this was my initial array. From this array, when I had to get this the array with excluding the first element, what did I do? I took slicing from 1 to end. Is this clear? Now from this array, this whole array, if I need to get the further array of first element onwards, what will I do? I will further add 1 to it, isn't it? Tell me what is the doubt. Tell me what is the doubt that's going in your mind.
Okay, so like we were thinking on a second step, after 1 colon, you will write 2 colon. So that was the thought.
See, that is also possible. That is also right. But I'm not right now. I'm just breaking using the previous array because I am just taking the reference of previous array and adding it. Right. So 2 column is also possible. That is also right. I'm not saying that is not right. Just a second. So you can either write down it as array of 1 till n and then further this, or you can write it down as array of 2 onwards. These both are same, isn't it?
Right.
Yeah.
But if I have to write down this in terms of my previous array, right? So I will write it down like this because this is my first array, right? So I'm writing down it in terms of my previous array. That's what I'm doing. Any doubt, anyone till this point?
No, clear.
Okay.
No.
So this is the pattern. The what pattern did I see? That I will take the first element of the array. Okay. First element of the array, multiply by the product of the remaining elements of the array. Correct? Now, what is the product of the remaining? It is equal to the first of the remaining part, then the product of the remaining, and that's how we will keep on iterating. Is it right?
Yeah.
So let's write down a recursive function for this. So let's say def product. Okay, I'm taking an array as input. So what I'm doing now, first of all, see if my array has no length, let's say it is blank. So if length of this array is equal to 0, you can return anything. For example, you can return 0, 1. That's totally up to you. Okay. Now, so this is your base case, which we did. This part is clear, right? If there is nothing, if element has, if your array is blank, then you will return 1 or 0. It's up to you what you want to return. Now you write down the recursive condition. So what is the recursive condition here? Recursive condition will say that return array of 0, that is the first element, okay, multiplied by what? What did I do here? First element multiplied by
Rest all numbers.
Product of them.
So I'll call the function again. Okay, product. Then I have to which element will be there now? Remaining of all the elements. Am I right?
Yeah.
So what will I write down here? I'll say array of 1 onwards. That's it. Is this part clear? Now let's call this. Let's call our array equal to 3, 6, 10, 23, 42, for example, anything. I'll call product of ARR. So it will give me the product of all the elements. Is this clear, everyone? What I'm doing here? Why I'm calling the recursive function? What does this mean? Any confusion before I move ahead to the next question? So I have pasted the code here. Okay, you guys can refer it. So now let's move to the next question. Reverse a string. So you are given a string. What you need to do? You need to generate the reverse of it. So can someone suggest me how to do this?
I think by slicings only we can achieve this, right?
Yeah. So let's try to understand first of all using an example. So do you guys know this? For example, let us say you have this particular string. Let's test this out. Let's say you have a string S1 is equal to ABC, okay, and S2 equal to DEF. If I write down S1 plus S2, what will come? Will it give me an error or it will give me something? Tell me.
String A B C D E
Will
F.
it give me a string or it will give me an error? Because this is I'm adding maths to string, because like
It
plus.
will add to string, no? Like A, B, C, D, E, F.
Sorry, can you repeat?
It will give string A, B, C, D, E, F.
A, B, C, D, F, right? So
Hmm.
in strings, whenever you add things like this, they just concatenate them. Okay. So I'm going to use this particular concept here. So for example, let us say I have this string hello. So let's say I have this string equal to hello. I want to create the reverse of it. Okay. Generally, we know that we will take S and we will do that, right? That method is always there. Okay. Now, what I'm going to do, what is the reverse of hello? Is equal to O L L E H, right? This is the reverse of hello. Okay. Okay. So we take the string and yeah. So someone was suggesting me how to solve this particular. I want to hear your thoughts.
So like we start indexing from 0 to 1. So in case of reverse, we go from minus to 0. I believe that will work. Not
Yeah.
sure.
So what will happen? Your first element, which was your first character here in the original string, it will go towards the end. Am I right?
Right.
So okay, and then this so what so can I write it down that I can say that reverse of S string is equal to reverse of ELLO, okay, plus H. Can I say this? What is H? H is the first element of the string. What did I do? I took my first string, I took the first element, move it to the end, okay, and then I'm applying the function again, that reverse of the remaining part. Then, and the only thing is that I took the first part, I moved it to end because I need to reverse it.
Rather, here we can also come from the end, right? End of the string.
But you need to reverse the original string. So why will you come from from the back?
Yeah, first we take the last element of the string and then we add it and then call the recursive function till.
Yeah, that is also possible. Like you do it the other way.
Yeah, okay.
So like you can say that a reverse of S is equal to O, that is the last part of the string, plus reverse of HELL, right? So what is the reverse of H? It will be OLLEH. That is also possible. Okay, so technically what I'm doing, I'm taking the first element, okay, towards the end, and I'm taking the reverse of the remaining element. So if I just have to code this now, how will I code it? Let's see. So def reverse string. Okay, let's say this is the function. Now first let's write down the base condition. What is the base condition? If the length of my string is less than equal to 1, I will simply return string, right? Because if there is A only, or if there is B only, the reverse means same itself. So I will say if length of let's say string S, if this is less than equal to 1, okay, so what I'm going to do, return S. Is this part right? Now I need to add the recursive case. So now add the recursive case. What is the recursive case? I'll return. Now I need to reverse it, right? So I need to take the original string, the remaining part of the original string. So what I need to do, so just like previous question, I need all the strings starting from the second index, right? So what I will do, I will say that, okay, let's do one thing, call this reverse string function, okay, on original reverse string on original that string from 1 onwards, okay, this plus in the original string I just need the first element. Think and let me know if this particular thing makes sense or not. So please validate it, let me know. Yep. So tell me, does this make sense now? That how am I reversing the string? I'm taking the first element, moving it towards the end, and then I'm applying the same reverse string function on the remaining part of the elements, and then it will keep on looping just like we did earlier. Okay, this is the recursion, the basic example. So let's move to the next question. We have done 3 questions now. Let's move to the question number 4. Question number 4 says, write a recursive function to count occurrences. So you are given a string and you are given a character. You need to tell how many times is that particular element coming in this particular string. So how can I do it? Can I think for a minute? Let me know.
We have to use recursion only.
Yes, recursion only. Like there are multiple methods. Right now, we just want to solve using recursion. Just tell me how can we do coding. I will do. Just think how can we do.
So here we'll
How
take a
I'll
count. So we take a count of the character each time and then pass the same count to the recursive function.
But how you where are you checking the count? Like I want to check if this element is present in this list.
Yeah. Initially we pass it as 0, and then if that if character, I mean we check the character. We can write if else, right?
Yeah, we can write on that.
Yeah, and then return with the count.
So what I'm going to do, let me tell you, is that, for example, you are again given a word, let's say string hello. Okay. And suppose you are asked, tell me how many times is the word L coming in this. Okay. Now, so in recursion, we simplify the case. So what we will do, we will see, okay, instead of comparing with the remaining part, let's compare this with the first element of the string. So what I will I will check if L, that is my this part, is equal to my this, let's say this is my string's first element. Okay, then I will put a count equal to 1. Otherwise, I will put the count equal to 0. Okay. And then I will keep on repeating on the remaining parts as well. Okay. So what did I do? First of all, I checked with H. So let's say this is hello. Okay. Now this is L. Now let's say step 1. I will check. I'll compare L in H, like this string, plus then I will check with the word LO later on. I'll write down a function where I will check in LO. Now this line will give me either 1 or 0. Now because L is not equal to H, right? So it will give me 0. So S1 will become equal to 0. Then I need to call a function where I need to check L in function for L in LO. Okay. Now, how can you get this part? This is exactly repeating the same activity again. So if you have to check in LO, what you will do, you need to check the L. So you will compare with the first element. So you'll compare with E plus LLO. Okay. Now when you compare with E, it will give you 0. So far the L is appearing 0 times. Now you will compare with LLO for L. Now do the first comparison. This will give you 1 plus LO. Okay. Now let's move next. Now because you have got 1, now in LO, if you compare with L, what will you get? You'll get one more here. So 1 here, 1 here. Okay. With O you will get 0. So total count is 2. Understood, or it went above your head? Or you want me to explain once again?
Yeah, please.
Think like this. Okay. So let's say this is H. So this is my main string. In this, I'm checking the character L. Okay. I need to test this particular L character in this. So what will I do? First, I will compare L with the first element of hello, right? So what I will do that H will come here. Okay. Then these whole words will come separately. So these will be here. Okay. Just like earlier, E, L, L, O. Okay. And here what have I done? I am just adding it like this. Okay. Now I'm comparing. Is my H is equal to L? What will it give me?
False.
False.
False. It will give me false condition, right? Which means 0. Okay. So here I have 0. Now how to get in this particular LO? How can you do this? So it will be E, right, plus L, L, O. Is it right? Now you will compare E with L. Is it right? Now let's go even further. Next you will compare with L, because this is the first element. Okay. Now L and O. Okay. Next, after that, you'll compare with L, and then you will leave the O part. And then you will compare with the O part. So what is happening is you have this plus plus. Okay. Right now, things will start from here. First, you will check, is O equal to L? Tell me. Is it true or false?
False.
This is false, right? So in O, the value is 0, correct? And in this L, is this is equal to L? This will give me 1.
True.
Overall, for this LLO, for LO, what do I get? Value count as 1. Am I right? So what is the count in LO? Count in LO is what? 1, because I got it from here. Now this will give also 1. So overall LLO, this will give me how much count?
2.
2. So this LLO becomes 2, right? And this ELLO, this will give me 0. So overall, this will give me 2 count only. Okay. Now let's go ahead. Above here, this is 2 we got from previous case. Now this H, this will give me 0. So overall remains 2.
2.
Do you understand now how we did it?
Yeah.
We'll compare with the first element, and then we will write down remaining as a function of the original function, and then we will back propagate to solve, just like we were doing for factorial and others as well. Is it clear?
Yes.
So, how to write the code for this? I'll say def count occurrence. Okay. So sorry, count occurrence. I'll get a string and I'll get a character. Okay. So first of all, I write the base condition. What is my base condition? If my length is 0 initially, I'll return 0. Okay. Then I'll write down the recursive case. Recursive case says that count is equal to 1 if S the string that is given, if the first element of my original string is equal to char. Okay. Else I will mark it as 0. Okay. So if my first element is equal to char, I'll mark it as 1. Otherwise, I'll make it 0. And then what do I need to return? I'll return this count plus what I'm calling next. This count gave me only from the first element. In this string, there are multiple elements. Remember, this is like this. It gave me only with comparison with the first element, but I still need the comparison with the remaining of the elements. So what will I do?
We'll call a function for string from 1 to
I'll
n.
call back my function count occurrence, because in recursion you have to call your function. That is what recursion is. Okay. Now what will the parameter? Remember, the first part I have already compared. So what do I need? I need the remaining parts. So S1 onwards. Okay. And what I need to check with it? I need to check with the character. That's it. Let's check it out, the value. For example, Mississippi S. It is coming out to be 4 times, right? So let's check it out if this is giving the right result. So S equal to Mississippi, char equal to S. So I call the function count underscore occurrence S, comma char. Sorry, this is S. Yeah, it is right. So I've got 4 as answer. 2S, 3, 4. Clear, everyone? Any doubt?
Yes.
Okay. Now let's solve the last question. Then we'll move to the sliding window. GCD. Okay. Do you guys know how to calculate GCD? Because for this you need a basic information that how to get the. There were 10 questions. Oh, I forgot. Okay. So probably we'll do the 5 remaining. We will do. Because I have to cover sliding window as well. So-
When I downloaded the sheet, it had only 4 questions. So how is like there are
Maybe
7?
I updated it later on.
Okay, because I remember I have solved 4 and submitted 4 because in my sheet there were only 4 only.
Okay.
Yes, even the download, even what I downloaded
Okay.
was having-
Remaining we can do later. Let's focus. Let's shift to a sliding window then, right? We can do this later. These are simple questions on just like I did. Let's move towards solving the sliding window because that is more important. But this part you understood, right? Recursion, how to solve using recursion. That what is the basic intuition? You need to think. So it requires little bit thinking that you are given a question and you need to try to break it down into sub levels, right? Just identify one pattern and just apply that. You don't need to like every time you don't need to write down, explain things like me that I am doing. If you understand it, very fine. Okay. So now let us understand the sliding window. Who all didn't understand the sliding window? I gave in the sliding window video, I explained one question, 2 question actually. Were you able to understand them?
Yes.
So let's try to visualize that particular question once again. Okay. And then we will solve the remaining of the questions. So sliding window. Wait a second. So let's say we have this 21528 and we have S equal to 7. Okay. So let us say you have an array of size. This is an array 21528. Two, 1, 5, 2, 8. Right. So let us say it is present 2, 1, 5, 2, 8. S is equal to 7. So let's study what the question is saying. The question says that given an array of positive integers and a number S, find the length of the smallest contiguous array whose sum is greater than or equal to S. Okay. So there are, what is contiguous array? Contiguous array are those which are basically continuous. Like 215 is a contiguous array. Okay. 215 is a contiguous array, but 218 is not a contiguous array. So subarrays which are part of this, which appear together inside this particular array, that they are called contiguous array. Okay. Now I need to find the length of the smallest contiguous array whose sum is greater than equal to S. So if you see every contiguous array will have sum. I want to find that particular array which has minimum length, right? But whose sum is still greater than equal to 7. That's what I need to do. So we use the concept of dynamic window here. So what we do that we will start from the first element. Okay. So we'll start from this particular element and we'll keep a variable length. So what I need to do first, so let's say my window starts from here. Okay, so initially my window is going till here only. So what is the element that I see with myself? It is 2 only. Now I will check when I have the first element, is that sum. So let's say this, because this is my first contiguous array, this 2 is the first contiguous array. Is this sum greater than equal to 7? Yes or no? Is it greater than 7, greater than equal to 7? Yes or no?
No.
No. So to reach to because we need some greater than equal to 7, what we need to do? We need to increase. So what will we do? We will increase. Okay, let's include the next number as well. Now my function become my this becomes 2 and 1, right? Okay. Now is the sum of this contiguous array greater than equal to 7? Yes or not?
Not.
Because sum is 3 and original was 7, right? So I will again expand my window. Okay, so what I will do, I'll say, okay, let's expand my window. I get this as, now tell me, I get 5. So what is the sum? Sum is equal to 8. Is 8 greater than equal to 7?
Yes.
Yes. Yes.
Yes. So the moment I find an array which satisfies the condition that sum is greater than equal to 7, I will put my put 1 here, increase my counter by 1 here. That okay. So the length is 3. This is my first element, right? So far now I have met only first contiguous array whose sum is greater than equal to 7 and whose length is 3. What should be my next objective? I need to find the smallest subarray. So I need to look if there is a further smaller array than this which can give me sum greater than equal to 7. Okay. Now, whenever you reach this condition, now this, remember, we have this window right now. I know if I increase this, sum will already be greater than 7. That is not going to give me anything. So what will I do? I will shrink my window from the left end. Okay. So I will say, okay, once I have reached a condition, I will shrink my window from the left end. Okay. And this becomes my new window. So what is my new window? 1, 5. Now I will compare. Is my 1 plus 5 greater than equal to 7?
No.
No. So because it is not greater than 7, now I need to increase. So let's do one thing. Increase this window. Okay. I reached here. Okay. Now what is the sum? 5 plus 1, 6 to 8. This is greater than equal to 7. Okay. But will my length be updated? Even though I have got a new array whose sum is greater than equal to 7, but its length is still 3. So it has not given me any advantage till now. Agreed? Yes or no?
Right.
So what I need to do now, I need to reduce my contract my window. So what I will do, I'll shift my left pointer. Okay. And let's say this is my new updated window. Now, what is the sum of this particular window? 7. Is it greater than equal to 7? Yes, that I have. Yes. And also I see that the length is less than my previous current length, right? So I will change this. Now my length becomes 2, right? Because this is my element. Okay. Now I have to see that, can I further contract it and see, is there is my sum still, does my sum still remains greater than equal to 7? So what I will do, I'll further contract it. Okay. Now my element is 2. Is 2 greater than equal to 7? No.
No.
So what I will do, I will expand. Now it will expand here. Okay. Now I got 10. 10 is greater than equal to 7, which is true. But what is the length of this? 2. So it is not helping me in my result. So what I will do now, I will contract. So if I just contract it, I get an element 8, which is greater than equal to 7, right? So, and whose length is 1 only. So I will change my length overall to 1. So this is my smallest contiguous array whose sum is greater than equal to 7. Is this approach clear to everyone? Or you have doubts? Right
All
now,
clear.
I'm just discussing the implementation, not the coding part. So we have to constantly increase, contract the window, and we have to constantly expand the window. Yeah, I will share the notebook. Tell me, is this method clear to everyone? How theoretically we are doing? So let me summarize the steps. The step is that we will start with a window. Okay. First of all, we will try to reach to a window which gives me a target, right? Reach to a window which gives me a target. Okay. And I will store its length. Now I know that I need to minimize the length. So what I will do, I will contract from the left. Okay. Now I'm contracting from the left. I will see, do I see anything? If I don't find any better result, I will expand. Okay. And this cycle I will keep on repeating. Contract, like if I have to increase the context, I will expand the window. If I have to reduce, I will have to see, can I get a better result? I will contract the window, and that's how I'm going to achieve the results. So all good till this point? Okay, now let's go toward discussing the assignment. In the assignment, this particular question I have already shared, right? If you see, you will find this code here only, so you can refer. I have already created the video on second question, so you can check that. So I'll be discussing question number 1, question number 3. Okay, question number 1 and 4 are identical, so 4 I'm not going to discuss right now. 1, 3 and 5, I'm going to discuss 3 questions in this class. Okay, so first let's discuss about question number 1. Where is it? Okay, longest sub array with at most k distinct elements. So suppose you have this particular array 1 2 1 3 4 2 3. One, 2, 1. What is the remaining? 3 4 2 3. 3 4 2 3. Okay. So what I need to find, given an array of an integer k. For example, k is equal to 2. Find the length of the longest subarray that contains at most k distinct elements. Okay, so we are given there is a value. I need to find the length of the longest subarray, right? Length of the longest subarray which contains at most k distinct elements. So longest subarray which contains at most 2 distinct elements. Okay, so what does it mean? For example, let us understand. First of all, if I see this whole array, how many distinct elements does whole array contain? 1 2 3 four distinct element it contains, right? The full array contains 4 distinct elements. So can it be the answer?
No.
Right? We want those array which contain at most 2. So let's start. Let's look at this. One can be one such subarray. Correct? Can 1, 2 be 1, 2 can be such subarray. Okay. 1 to 1 can also be such subarray because it has 2 distinct elements. 1, 2, 1. Now 1, 2, 1, 3, can this be there? No, because 1, 2, 3, it contains 3 distinct elements, so that is not possible. So starting from 1, I see that there only these 3 subarrays are possible with 2 distinct elements. Let's look at the subarrays which are starting from 2. So 2, 1. Yes, 2, 1 can be one such subarray. 2, 1. Now 2, 1, 3. Can it be? No. So starting with 2, only this array is possible. Only this subarray is possible, right?
2 alone is also possible.
Sorry?
2 alone is also possible.
Yeah, 2 alone is also possible. Sorry. Yeah. 2 alone is also possible. Now let's see. Starting with 3. 1 will be the 1
But
with 3.
Satvik, how can a single number can be possible? It should have 2 distinct.
No, at most 2 distinct.
Oh, at most. Okay.
So at
Okay,
most 2
got it.
distinct means
At
that 1
least.
or 2.
Yeah.
Okay.
Okay.
3. So 3 or 4. Okay. These subarrays possible. Now starting with 3, only these 2 are possible. Okay. Starting with 4 is possible, and 4 and 2 are possible. Starting with 2, this 2 is possible, and 2 and 3 are possible. Okay. And starting with 3, only 3 is possible. So out of all these subarrays, which subarray has the biggest length?
1 to 1.
Right? So we need to find this particular subarray which has the biggest length. So is the question clear to everyone that what we need to do?
Yes.
Okay. So we need to identify, we need to solve this particular question using okay. So what I'm going to do is, whenever I'm creating a window, so let's say select a subarray. Let's say, because I'll start from left. Okay. So let's say this is my context window. This is my window. Whenever I create a window, parallelly I'll create a dictionary. Okay. And in that dictionary, I'm going to store all the distinct elements and their count. So when I have this 1, okay, there is only 1. What is the frequency of 1? It is 1. Am I right?
Yes.
Now I will increase. This. So I will increase this from here to here. When I increase, I get another value 2 with a frequency of 1. Okay. Remember, ideally the length of my dictionary should be less than equal to 2. So what is the meaning of length of dictionary? Number of keys, or how many keys are present in my dictionary. Okay. So the length of my dictionary should always be less than equal to 2. Okay. Now, let's say I increase it further. So what do I see? That frequency of 1 will become 2. Correct? Is it clear till this point?
Yes.
Now, when I include the next point, now when I further expand my window, what will happen? I will get a 3 with a value of 1. Is it right? So whenever I encounter, whenever I see this condition that length of my array becomes greater than 2, okay, what do I need to do? Can you suggest me?
Remove the left element.
Yeah, so I will contract my window. So I will remove this from here. Okay, I'll contract it. Now, once I contract this, the frequency of 1 will reduce by 1, correct? So the frequency of 1 will become 1. But even after contracting, I see that my number of the length is still greater than 2, right? So what will happen? I will have to contract it further. Now, whenever I contract, so now I see that 2 is out. So after performing this operation, I will remove this 2 from the dictionary. Okay. Now I have this particular length. Okay. So far, which was my biggest length? My length was 3, highest so far what I encountered. Now I will further. Now what I will do, I'll further increase the window size. Now once I increase the window size, what will happen? The third element, the 4 1 will come. So what will I have to do? I will have to parallelly contract as well. So once I contract it, I will have to remove this part. 1 will be removed from here. Okay, and this process will go on till I move to the end. So is the step clear to everyone? So I will start navigate, iterate from left to right. Okay, I'll use a dictionary. Okay, whenever I see that the length of my dictionary becomes greater than 2, I will remove the element from the left, and I will keep on repeating the same activity. So is the intuition clear to everyone? That how to logically do it? So now,
Patrick, hello.
yeah, please.
Yeah, so like in previous questions, we were doing the window something. So here we are doing this dynamic dictionary kind of a thing.
Yes.
Right.
See, you do some more dictionary, that does not matter, because eventually we are using sliding window, right? Now, depending upon the question, you need to change the concept.
Okay.
So taking the sum is not dynamic window. That was just for that particular question. Is it clear?
Yeah.
No, it's not clear. I can sense.
No. I was just saying that, like it is happening at the same time in the code, like where we were like in the previous question where we were doing the window sum. So we were taking a window size, like window sum. There only we will now be doing the dictionary. So in my head, I was saying that, but I'll see where in code it will happen.
No, I'm writing on the code. Don't worry. So you will see that. Okay, so first let's write down how to do the code, this particular code. So we have this array and we have k. Okay, so first let's write down def longest subarray. It will take an array and it will take a k value. Okay. Okay, so what I need to do, first of all, the step 1. So I'll create a dictionary. Okay, I'll create a blank dictionary, basically blank dictionary and pointers. So let's create a blank dictionary as Frec is equal to blank. Okay, this is my blank dictionary where I'll be storing the frequency of element. So let's say my left pointer is 0, and right now I will be storing the maximum length, right? Because I need to calculate the maximum length longest subarray. So initially let's initialize it with 0. Okay, this is the initialization that I am doing right now. So now I will need a right pointer. Okay, so I'll create a for loop. So for right in range of length of array. Okay, so what I'm doing for right in this particular range, so now I'll be looping, I'll be iterating through from here till the end. Okay, so now look at this way. What is happening? First of all, I'll be checking with 1. Okay, I'll check with 1, then I will check with 1 comma 2, then I will check with 1 comma 2 comma 3, right? And that's how things are going, right? So for every write, okay, what I need to do, if array of write in frec, if it is already present, then what do I need to do? Whenever I encounter a new, so whenever what is up, I'm starting from here, right? This is my first step. So whenever I encounter a new element which is already present in frec, what will I do?
Then include that in
Increment the count.
Increment the count by 1. So frec of right plus equal to 1, right? Else, and if I'm seeing for the first time, then what will I do?
Make it 1.
into the dictionary.
Frec of right equal to 1, correct? This is what I'm doing now. So what is happening? Every time I'm encountering a new value, I'm just adding it to the dictionary. This part I have done now. Now I need to, so this is called expansion. Now whenever I see, now I need to write down the condition that whenever I see a number which is where length is greater. So what I mean to say that while length of frec, okay, is greater than what is, when it is greater than k, right? Because I'm given at most 2 distinct elements, right? So whenever I get those cases when my length of element is greater than, so what will I do? What was happening here? Whenever I was encountering a new element here, I was removing reducing the frequency of the left because I was shifting the pointer, right? Till this particular point, my frequency was 1, 2, 2, 1. Now, when I moved here, what happened? I saw that I get a value 3, 1, and now my length is greater than 2. So what did I do? I removed the leftmost element. What do you mean by removing the leftmost element? It means reducing the frequency of the leftmost element by 1, minus 1. Is it correct? So what will I do? While length of this is greater than frec, I will do frec of array of left pointer. What will happen?
Minus equals 1.
Minus equal to 1. Okay. Is this part clear?
So I have one question that if something was coming like once, and when we do it -1, so it will become 0.
Yeah, so that I'm going to do next, right? Now, if it becomes equal to 0, okay? Now, if by doing the above operation, it becomes equal to 0. So if frac of array of left becomes equal to 0, what will you do? You will delete
Point from the dictionary.
from the dictionary frac of array of left. Is it clear? And you need to do one more thing. Can you tell me? So what did I do? Whenever I encountered a new element, I reduced the
Left,
frequency of
left counter.
I need to move the left pointer ahead by 1. So what I will do, I'll do left plus equal to 1. Okay. This part I've done. Now, see, initially my max length was 0. Okay. So now tell me this thing. For every step, let's say this is I. Let's say this is I, this is J. What is the length of this array? Let's say this is the left pointer, this is the right pointer, index. This one, L and R. What is the length of this array in terms of R and L?
Right minus left plus 1.
Plus 1.
R minus L plus 1, correct? So for every loop, this is the R minus L plus 1 is my length of that particular window. So what I have to do now, eventually what do I need to return? I need to return the maximum length, right? So what I will do here, I will do that max underscore length is equal to max of what? Already present max length, right? And it will be right minus left plus 1. Okay. And then what do you need to return?
Max length.
Max length. Just a second. This is the code. Do you get it, or it just went above your head? Any doubt, anyone, in this approach? I'll copy the code to the chat box. You can check it. Okay, so remember, we are keeping a dictionary count and we are reducing, just like we were doing in the previous case with the sum. Here we are playing with a dictionary. That's all we are doing. Okay, so now let's test it out on. So we had this, right? So now let's do one thing. Longest sub array. I'll simply call this. Very good. Frac of right plus equal to 1. Where is it? Frac else frac of right equal to 1.
I think it would be ARR of right.
Is it frequency?
Oh,
or
sorry, frac of ARR of right. My bad. Yeah.
else, even in else part?
Yes. Got it? So this is the 3, 1 to 1, which was present. 1 to 1 was the longest subarray. Okay. Clear, everyone? So just sending you the updated code as well. You can check it. So I have a time constraint, so I'll be able to discuss one more question only. Rest we will cover later. So let's move to the third question. Okay. That is, count sub arrays with exactly k odd numbers. So can you tell me how did you do, or what shall we do for this particular question? Like those who are solving these questions for the first time, it's totally fine. You will not understand everything in first go. So don't worry about that. A little bit of practice is required. So we need to get used to solving at least 10-15 questions of this type, so that you start getting the idea. And trust me, these questions get repeated in interviews. So that's why, I mean, even if you remember or if you know these approaches, right, you can directly apply in interviews. So these are like some standard questions that are generally asked in interviews. So yes, please.
Hello.
Yeah, please.
Yeah, in this question, we need to find, we need to have two k odd numbers. So in the first test case, we have 1 to 1. So 1 and 1 are two odd numbers available here. And then 212, 212 is only one odd number. It's not, we are not getting two odd numbers here. So how is it? So can we take 212 in this case?
With exactly two odd numbers. So this will not be present. This will be present. This will be present. Yeah.
And that can be like, okay, yes, yes. Then exactly, if we are counting exactly, then 21 is also not possible.
Why they're asking two odd numbers? So, okay, yeah, 1 is also not possible. Yes. So 1 to 1 has two. 1 to 1 has so 1 to 1 is possible. 1 to 1. So only 1 to 1 will be the answer for this particular case. So how many subarrays are there that contain exactly k odd numbers? So only one such array is there. So like, let me check.
They're coming two times, right? I mean, they're the same
Yeah,
subarray.
yeah, 1 to 1 is coming two times, right? So one is here and one is here. So it will come. Yes, right, right. I was just checking that. Sorry. So if you look from here, this contains one odd. This contains two odd. Okay. This also contains two odd. Okay. And so there will be multiple cases possible, right? Like first of all, this 1 to 1 is there. Let's check those subarrays starting from 1. So 1, this will not be there. This will be there. This will be there. So 1 2 1 2 will also be there.
2 1
Right.
2 1 will be there.
Sorry.
2 1 2 1.
I'm right now I'm talking about starting with 1. So 1 2 1 2 will be there. So okay, now let's talk about things which are starting from 2. So it will be 2 1. Okay. So 2 1 will be one such number. Then it will be 2 1 2. No, 2 1 2 will not be there. 2 1 2 1 will be there.
2 1 will not be there because we need exactly 2.
Yeah, so 2 1 2 1 is there, right? That's what I'm saying.
2 1, only 2 1. The third
2 1 I've included. Now
It won't be there. 2 comma 1 won't be there because we need
it has only one odd number.
but we need exactly two odd numbers.
Okay, so let's remove this one.
Yeah.
Is it clear? The cases. So 1 2 1 2 2 1 2, like these cases are present there. Now, so how did you guys? Okay, forget. I mean, we understand what we exactly want, but so what do how to approach this particular?
Like we can make a dictionary like we did previously and count the number of odd numbers appearing in the dictionary. Like maybe like that we can do.
We can create a dictionary and keep a count of what is the count of odd numbers in that, right? So we one method is that, yes. There's another better approach here is that when you're finding k odd numbers directly, the problem is that once you increase the window, that is a method. There is another method which we generally follow for this type of questions is that uh, tell me this. Let's say if you find the sub arrays, find sub arrays with at most k elements, with at most k odd numbers, okay, at most. And then you also find sub arrays with at most k minus 1 odd numbers. So let's say this is equal to n, this is equal to m. Then can you say that n minus m is equal to sub arrays with k odd numbers?
Yes.
Can we say this? The problem is that I'll explain you when we code, but like I don't have much time right now. But when you start creating a dictionary for calculating only the odd numbers, you there are multiple loops, okay, and you need to write lot of if else condition. That criteria is also right, that method is also right, but it is a little bit lengthy approach, okay. So like you realize that do code that way as well, but I'm going to follow this particular method because it is short and it is effective. Like you will be able to understand it, okay. So thing is that you will take all the sub arrays with at most k plus 1 elements, okay, and then you will take all the sub arrays with at most k minus 1 elements, then you will reduce subtract them, it will give you the answer. Is this logic clear to everyone? Anyone, any doubt in this logic before I start coding? What is the doubt in this?
I didn't understand that k part, like how n minus m is giving k subarrays.
So let's say k's value is 2. First, let's get all the sub arrays which have maximum 1 odd numbers, okay. Sorry, so which have, yeah, so let's get all the sub arrays which have at most 1 odd number. So what all numbers can be there? Let's say so it could be, okay, tell me this thing. When you say sub arrays with at most k odd numbers, what all will come inside this? This means sub array with at most k minus 1 odd numbers plus sub-arrays with k odd numbers. Is it right?
Yes.
So that's what I'm doing. Just take it here. Sub-arrays with k at most k odd numbers minus sub-arrays with at most k minus 1 odd numbers. What will it give you? It will give you the sub-arrays with k odd numbers. That's what I'm saying. Here now?
Okay.
Any doubt in this logic?
It's clear. It's clear.
Okay. Now I need to find in, let's say you're given a sub-array, for example, 1, 2, 3, 4, 5. Okay. One, 2, 3, 4, and 5. Okay. And let us say the value of k is equal to 2. First, let's calculate a general function, a general method where given value of k, we can identify the sub-arrays, all the sub-arrays which have at most k odd numbers. Okay. So what we will do, I will start with all the sub-arrays from, so I will start from 1. Okay. So let us say I start, my left point is 1. Okay. So left pointer is 0, I mean, right, and my right pointer. So this is my first. Okay. So how many sub-arrays are possible? Such sub-arrays are there.
3.
Sorry?
3. 1, 1, 2, 3, 1, 2, 3, 4, 5.
I'm right now, I'm only till 1, till only this point.
Then 1.
Only one array, right? And remember, this 1 is an odd. Okay. So now let's move. So now my right was at, my left is 0, my right pointer is also at 0 right now. Okay. So whenever so what do I see? How many odd sub-arrays are there? Right now I have odd sub-array equal to 1. Okay. Now when I increase my right pointer to 1, now when right equal to 1, so what happens? My window shifts from here to here. I encounter a new element number 2, which is even, right? So the array of right pointer is even. Now tell me how many odd subarrays will be there?
2. 2 sub-arrays will be there.
Right? So there will be two subarrays, right? So one will be 1 and one will be 1, 2. But 1 is repeating. This one we already encountered earlier. So how many new subarrays are possible? Only 1, right? So whenever I'm encountering a new element, how many new subarrays are there?
It's adding 1, like same number. Like for 1 it is 1, for 2 it is 2 sub-arrays, for 3 it is 3.
So when I encounter 3, how many odd subarrays will be there?
1, 1, 2, 1, 2, 3.
And what about 2, 3?
But we are starting from 1 now.
No, we are only finishing at, this is the point. We are not starting on, we are checking a right pointer. So whenever I'm moving, I'm checking how many subarrays are possible till here, how many subarrays are possible till here, how many subarrays are possible till here, how many are possible till here, and how many are possible till here. That's what I'm checking.
Then it will be 4. Excluding the first case.
So the number of sub arrays at any right pointer will be equal to right minus left plus 1. So I'm going to use this particular logic only. Let me explain you through code only. Okay. So let's do one thing. So I'll create def, let's say count subarrays. Sorry, count subarrays. Okay, I'm giving it an array and I'm giving a value of k to it. Okay, this is I'm giving. Now I need to use a helper function first of all, because I'm going to use that helper. So what that helper function is going to tell me that given an array, okay, and a k, I will tell you how many sub arrays are there, which are basically which contain at most k distinct elements. Okay, so what I will do, def count at most k. Remember, my main function is to get count sub arrays with k odd. Okay, this is my main function. Inside this, I'm using a helper function. So this will take any array and it will take the k which I passed above. Okay, now what I need to do, that first of all, let's do left equal to 0. Okay, and let's say my odd, I'll create an odd count which is equal to 0. What is odd count? Odd count is that whenever I'm encountering a new element, when I'm moving from left to right, let's say I move from here to here, so is my odd count increasing? Because right now I only had 1. Okay, when I increase from 1 to 1 2, is my odd count increasing? Yes or no? If I only had 1 2, and now if I increase to 3, my odd count is increasing by 1, right? So initially I'm setting it to be 0 and I will play with around when I move forward in the question. Okay, and I will use another variable count which will be giving me let's say, let's mark it as 0. This will give me sub arrays ending at the right pointer. Okay, so I'll speak about it as I move ahead. So first of all, let's do one thing. For right in range length of array. Okay, so what I'm going to do, first of all, I will start with the first element, then 1 2, then 1 2 3, and so on. I'm going to do, right, 1 2 3 4, and so on I'm going to do. So I say that if array of right, if this is odd basically, so what you will do, if this is not equal to 0, okay, so what will I do? I will, so whenever what does this it mean? That for example, my right value here is starting from 0. So whenever I'm encountering a new value which is odd, I am increasing the odd count to equal to odd underscore count equal to plus equal to 1. That's what I'm doing. Okay, is this much clear? Now what I need to do, so now this will give me lot of values. For example, 1 1 2 3 1 2 3 4. I need to filter out those where my number of odd count is basically less than 2, or whenever it is greater than 2, I need to handle it. So what I'm going to do right now, I'm going to say that while odd underscore count is greater than k, okay, whenever my odd count gets greater than k, what will I do then?
We will increase left.
Will increase left. Yes, will increase left, but I also need to do one more thing. If my left pointer is odd, I need to reduce my odd count by 1, isn't it? Because I'm removing the left element
So
from
we will
the,
decrease now.
sorry,
So we'll decrease it by
we'll
one.
decrease it by 1, right? So
Yeah.
we'll be doing 2 steps. If array of left percentage 2 becomes is not equal to, I mean, if it is odd, what I will do, odd underscore count will become equal to minus equal to 1, right? I'm reducing it by 1 and then I'm shifting my left pointer by 1. So left plus equal to 1. Is this much clear? So I am calculating all the arrays which are finishing, which are ending at the right pointer. Okay. Now, what I need to have this sub arrays ending at a right pointer are basically. So I will say count plus equal to right minus left plus 1. This particular code gives me the number of sub arrays which are ending at a particular right pointer. Tell me, any doubt in this particular part?
The last formula count equals to this thing.
Yeah.
Can you explain this, like last thing?
Okay. So suppose this is your left pointer, this is your right pointer. Okay. Now tell me how many sub arrays will be there. Okay. So let's figure it out. Okay. Or let's do one thing. Let's go from first. Let's start building from first only. Forget about this. Let's see when right is equal to left, when they are coinciding. So when right is 0 and left is 0, how many subarrays are possible? So
One.
when right is equal to 0, left is equal to 0, how many subarrays? Only one is possible. Is it right?
Yes.
Now when I increase r, left is equal to 0, r equal to 1. So 1, 2. So basically till this point, subarrays which are ending at point 2, how many subarrays will be there? Subarrays which are ending at 2.
2. 1, 1, 2.
1 will not be there. 1 I have already counted in previous case.
Okay. 1, 2.
So it will be 2 and 1, 2. Is it right?
Why 2?
2 is also subarray.
Okay, we are counting subarrays. Okay.
Now L equal to 0, R equal to 2. That is subarrays which are ending at this particular point. 1 will be 1, 2, 3, right?
3, 2, 3, and 3.
1, 2, 3 will be there. 2, 3 will be there. And 3 will be there. So if you try to notice what I'm trying to do, as I'm moving from here to here, I'm calculating how many subarrays are there which end at a particular right pointer. Okay, so there were 1 at this point, there was 2 at this point, there were 3 at this point, right? If you try to relate a formula, you will see that it is R minus L plus 1. Let's see. 0 minus 0 plus 1, correct? This is giving R minus 0. So 1 minus 0 plus 1, which is equal to 2, correct? So 2 minus 0 plus 1, 2 minus 0 plus 1, which is equal to 3. Okay, so number of sub arrays which are ending at a particular node, at a particular index, they are given by R minus L plus 1. Okay, so how I am iterating? Let's think from this point. I'm keeping a right pointer for, I'm looping basically. When my right pointer equal to 0, I'm calculating all the possible subarrays which are ending at that point. So let's, right, then when I am at R equal to 1, I'm calculating all the subarrays which are ending at 0, and I'm constantly adding them. Now someone will ask me, why are you not, why are you doing, so far we have been doing subarrays which start from left pointer only. Now why you're suddenly shifted to where you are counting subarrays which end at right point? Is this the question in anyone's mind, or can someone tell me why I'm doing so? Can someone tell me why I'm using the subarrays which are ending at right pointer, but we're not telling subarrays which are starting from a left pointer?
We have to take all the possible combinations.
Left will also have all the possible combinations. See, when I say that, tell me all the subarrays which start from 1. Okay, think, first of all, think, like, I don't want to spoon feed. Tell, I mean, you should be able to answer this. That's what I'm thinking.
We need both the pointers to find the subarray. Like we cannot take one pointer and find the subarray. Like we have to go till the end.
So we are going till the end using right also. Using left also, you can go. You start from here. You go till this, till this, till this.
Maybe because we are using the concept of at most, like because of that.
Think. I'm giving you 2 more minutes. it will be, let me give you a hint. If you use left ones, you will have the redundancy. Think now.
Because to remove the repeated ones, like remove the repeated subarrays.
Tell me with example.
Like suppose for the when L is equals to 0 and R is equals to 1, then for when L is equals to 0 and R equals to 0, then we have a subarray that is 1. But when we have L equals to 0 and R equals to 1, we technically we will have two subarrays, but that is because it is counted in the first case, we won't be taking that.
Exactly.
Like 1, 2.
Think like this. Let's say I'm using sub arrays which are starting from zero, right? So I will have 1 there, correct? Now when I increase my right pointer, so initially see my left is 0, right is 0. Okay, so which all subarrays are there? Subarray 1 is there. Now when I do left equal to 0, R equal to 1, I just explained this few minutes back as well. So my window becomes 1, 2, right? So what all subarrays are possible now? 1 is possible and 1, 2 is possible. So if you see, this 1 is repeating. Further, if I do L equal to 0, R equal to 2, I will get 1. I'll get 1, 2, and I will get 1, 2, 3, and I will get 2, 3. If you see, these two are getting repeated. Okay, that is why I'm not using the left one approach here. It is because my subarrays are getting repeated. So what I'm doing, I'm using the subarrays which are ending at a particular pointer, at a right pointer. Is it clear? So what I'm doing now, I'm checking all the subarrays. So I'll start with L equal to 0, R equal to 0. I will check all the subarrays which are ending till this particular R equal to 1. Let's say it gave me 1. Now I will check the subarrays which are ending at this point. It will give me, let's say, 2. Example, the number can be incorrect. Then I will check the subarrays which are ending at 3. Let's say it gives 3. It gives 4. And then I will sum everything. So it will give me all the subarrays with at most k distinct values. Is it clear? So that's what I'm doing here. I'm checking if so while count is greater than 2, I am like moving my left pointer here and there, and this is giving me the count of subarrays which are ending at the right pointer. Is it clear? So this function gives me the number of subarrays with at most k distinct values. Any doubt, anyone? Is it clear or not? Guys, yes, no. If it's not clear, let me know. I'll explain. Okay. So now what I have to do, remember I got the function which is giving me at most number of subarrays with at most k odd. What do I need? Number of subarrays with k odd. So remember, what did I tell you? That I will take a difference. So what do I mean? I will take this array k, okay, number of subarrays with at most k distinct values minus number of subarrays with at most k minus 1 odd values. And when I take the difference, it will give me the answer. That's all you need to do. Do one thing, after the session, you'll get the recording. revise this particular question logic once again, because when you hear for the first time, it takes some time to digest. So write yourself, write the code yourself, draw a diagram yourself, visualize multiple outputs yourself, then you will actually understand this. Okay, but this is the way to code this particular question. So because of time constraint, I'm stopping the session now. Like, we will continue. The last question is simple, but I will explain that as well. Okay, so let me know if you have any doubt. Otherwise, we can drop off. So we will continue in next session. So we discussed recursion and we discussed two problems of sliding window today.
Thank you.
No problem. But is it clear?
Thank you.
Sliding window. Any doubt? At least you understood the logical intuition. Go back and try on your own. The sliding window, like these 5 questions which I shared, and there are 3 more which I shared in the top 50 question assignment. If you do them, they are more than enough. Like, you will not be asked any question beyond this in interviews. So just grasp this concept properly. Okay, try this on your own. We'll discuss the remaining in the next session. Okay, and then now we will start the discussion with the top 50 assignments as well, top 50 questions as well from next class. Okay, so thanks again for attending the session. Right, so try these questions on your own once again and let me know if you face any difficulty. Okay, so thanks again everyone for joining.